So what is heteroskedascity? In a linear regression model, we want to assume that the error terms have a constant variance. Most of the time, they are not constant. This is known as heteroskedasty. For example, the variances of the error terms may increase with the value of the response. The problem? Ordinary least squares no longer produce the best estimators, and the standard error using the least squares is now incorrect. So my data is already imported into R, and now we want to build a single factor regression model in order to analyze the data. One way to detect heteroskedasty is through residual plots. Heteroskedasty can be visualized as a funnel shape. So now we're going to plot the data. As seen in the plot, the data points create a funnel shape, which tells us that heteroskedasty is present in our model. You can fix this by transforming the response y using a concave function such as log of y. This can cause a shrinkage of the larger responses, therefore reducing heteroskedasty. Another way to detect heteroskedasty is through the BP test. The BP test uses a variance function to test the null hypothesis that heteroskedasty is not present. The BP test assumes that the error terms are normally distributed. It tests then whether the variance of the error terms from a regression is dependent on the values of the independent variables. By inserting this function into R, we can conduct the BP test. Summary function, we can look and evaluate the p-value. By looking at the p-value, we can just determine whether or not you should reject the null hypothesis. If the p-value is less than the level of significance, then you reject the null hypothesis. Since our p-value is right down here, and this is our current value, heteroskedasty is present. So how do we fix it? In order to reduce heteroskedasty within the model, we need to load the lmtest and sandwich libraries and insert this function. We then use the coif test function to regress the robust standard errors, which addresses the issue of incorrect interval estimates. As you can see, the standard errors are two numbers that are very far apart from one another. We want to visualize the model with reduced heteroskedasty by inserting the plot function again into R. And then we see that the data points are no longer funnel shaped as they were before, and therefore we have reduced heteroskedasticity in our model.